Welcome friends, in this video I want to give you a kind of non-technical introduction to why, for example, we measure slope in calculus and why we have the derivative. So again, as long as you've climbed a flight of stairs, you'll immediately understand this. You don't need any fancy schmancy math symbols. Take a look. Look on the left side here. I'm beginning right here where my finger is located. I'm going to go 2 vertically and then 1 to the right. Now take a look. Something clearly happens at the next portion, right? Because now I'm going to go 1, 2, 3, 4, 5, 6 up, and then 1 to the right. So here, this step size, right here, if I were to actually climb this, is much bigger, you see that? Than it is over here. Here it's still pretty gentle. Here I would have to take a very big vertical leap just to get over to that point. Now what happens at that peak point itself? Well, I'm going to go 1 to the right, 1 over, and I get to that point. And notice right on the other side of the point, I'm going to go 1 to the right and 1 down. So here, notice that on the left side of that point, so to speak, the slope, in other words, is positive, and to the right of it, you see the slope is negative. Positive means to the left of it, I'm going to go 1 up, 1 to the right. On the right side, I'm going to go 1 to the right and 1 down. Now take a look. Let's repeat this. As I continue down my little curve here, I'm going to go 1 to the right, 1 down. 1 to the right, about half down. 1 to the right, again about half down. 1 to the right, 1 down. 1 to the right, and then 2 down. So you see that as you go down this staircase, right, the slope changes. In other words, the step size changes. Sometimes the step is very gentle, like here, for example, because you're going to go 1 to the right and then half down. And sometimes the slope is not so gentle, right? Because here, for example, you're going to go 1 to the right and then 2 down. So that might be a little bit hard to climb down over here, whereas here at this point, it'd be pretty easy to climb down, right? Because it's, 1 to the right and then maybe just a tiny amount going down. That's doable. That there we could experience as something pretty rough, right? If you're a tiny little person, that would be pretty scary. That could be kind of, easy to negotiate. So the big idea is that when you move along a curve like this, the slopes clearly can change. The step sizes can be quite different. And take a look. What happens at this low point? Well, take a look. I'm going to go basically 1 this way and then 1 down. That takes me to that low point right here. It's a bit difficult to see here, right? Because this box and this box are immediately adjacent. What's going to happen over here to the right of the low point? Take a look. I'm going to go 1 up and 1 over. It's going to take me to that point. I'm going to go 2 up and 1 over. And get 1 up, 1 over, and I get to another high point. What happens to the right of all of this? Take a look. 1 over, 1 down, 1 over, 1 down, 1 over, 1 down. 1 over, maybe half down, 1 over, a little less down, 1 over, just a tiny amount down. So here, if I were a tiny little Lilliputian, tiny person basically, climbing over here would be pretty easy, right? Think about it, because I would go 1 to the right and then just a little bit down. I could climb down easily. Whereas over here, if I were a tiny person, this would be a little more challenging, right? Because I would have to go 1 to the right and then 1 down. Here it would be kind of scary, right? Because 1 over and then 1 straight, oh, I'm sorry, 2 straight down. So the big idea is we have a curve and clearly the step size changes as you see here. So in calculus, we can kind of encode that by saying that there's a derivative involved. And the derivative basically measures the slope along the curve, the way you see here. But as long as you've climbed a flight of stairs in various kinds of configurations, you've already done this. We just formalize it with symbols. I want to study a little more what happens around the peaks. Take a look. So this is a kind of highly enlarged version of what happens around a peak as an example. Many other things are possible, of course, but this is an example. Take a look. Begin on the left side. Look, it's 3 up and then 1 over, 2 up, 1 over. 1 up, 1 over, 1 up, 1 over, 1 up, 1 over, 1 up, 1 over. About half up, 1 over, about half up, 1 over, half up, 1 over, half up, and then 1 over, and you kind of stop at the high point, you see? But this is still just a staircase, like that. The way you see it here. And then on the right side, take a look. Here, you have to look very carefully, right? I'm going to try to zoom in a little more if I can. You see, just here, I'm going to go 1 to the right, and there's just a tiny amount of going down. In other words, this chunk of the line right here is almost horizontal. You see that? The slope is very, 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 very small. It's almost a horizontal line. And the step size, if you look at it, it's almost difficult, almost impossible to show, in fact. Now look what happens as I continue my journey along the curve. I'm going to go one to the right and a little more down. One to the right, about half down now. One to the right, a little more down. One to the right, a little more down. Take a look at what happens on the next one. One to the right, 2 straight down. One to the right, 2 straight down. One to the right, 2 straight down. So also there's something else involved as an example, which is the concept of constant, for example, slope. Take a look. So here, when I go along this portion of the curve right here where I'm tracing, there's something special happening. Right? Think about it. One to the right, one up. One to the right, one up. One to the right, one up. Along this curve, you're taking the same step size. So you're not changing, you know, for example, how much you go up for each horizontal distance you travel. Whereas overall, if you look at it from left to right, you see there's a big difference because the step size is not constant. So you can have behaviors, you know, sometimes you can have something that looks like this, where the step size is constant, the way you see here. One up, one over, all 3 of those steps. But then overall, all kinds of fancy things can happen, like for example, various step sizes. 3 up, 1 over. Half up, 1 over. But these are all things that we study in calculus, and we study them through derivatives. But the underlying concepts that give rise to all of that, you can just, you know, illustrate with this. What happens, for example, on this original curve here at a low point? This point right here. Well, take a look. You can flip this way and it kind of illustrate what's happening. See that? So this particular case, take a look. You're going to go this way, for example. Get to the low point and then go this way, get to the high point. And what you observe about the staircase is 2 down, 1 over, 2 down, 1 over, 2 down, 1 over. Not quite 2 down, 1 over. A little bit down, 1 over, a little bit down, 1 over, a tiny amount down, 1 over. Here, it's just a very tiny amount that you're going to go down, and then 1 over. It's going to take you to this point here, where basically it's like a low point. So if you rolled a ball, that ball would settle at that point right there. It wouldn't have anywhere else to go. Now, to move it to the other side, obviously, you would have to push it, right? So here you're going to go 1 to the right, about half up, 1 to the right, 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 1 up, 1 over, 1 up, 1 over, 1 up, and so on all the way up. So at the low point, the same thing happens. When you get to that low point, you see that base slope is 0. It becomes like a little plateau at that point. So in calculus, we encode that by saying that the derivative is 0, essentially. Alright, that is it for this one. If this has helped you to understand some concepts related to, for example, traveling along the curve, slope, derivatives, and so on, if you see if I like it, I appreciate it. Thank you. See you in another video.